Use place value. Regroup when needed. Check with the inverse.
Welcome to the counting den. When we work with numbers reaching into the hundreds, keeping all those individual pieces organized can get complicated very quickly. We need a reliable way to sort every single unit, 10, and 100. This is a place value mat. It divides our space into 3 separate lanes. To keep our count accurate, we process numbers one lane at a time, starting with the ones on the right, then the tens, and finally the hundreds. Let's look at 358 plus 276. We've placed the units, the 10 rods, and the 100 flats into their respective columns. For this system to work, each lane has a capacity limit. It can only hold a single digit from 0 to 9. When we combine the ones, 8 plus 6, we get 14. Because 14 is a 2-digit number, it physically overflows the ones column. If we leave those 14 units where they are, we cannot read the columns clearly. To move forward, we need a way to handle this overflow without losing the value. Kit has a physical solution. By pushing 10 individual ones together, she creates a single cohesive bundle. In the den, we call this bundling. We take 10 units from our 14 and bundle them into a fresh 10 rod. Kit slides it over to the tens column, leaving 4 units behind. We record the 4 in the ones place, and the overflow is resolved. We use the same rule in the tens lane. 5 plus 7 plus the 10 we just carried over gives us 13 tens. We bundle 10 of those rods into a single 100 flat and move it to the next column, leaving 3 tens behind. Finally, we total the hundreds. 3 plus 2 plus the 1 we bundled. That's 6. By working through the columns, we find our answer is 634. This works because bundling allows any overflow to graduate to the next tier, keeping every digit within the 0 to 9 limit required by the columns. Subtraction follows the same logic in reverse. If we start with 503 and need to take away 168, we run into a different kind of problem. We have only 3 units in the ones column, but the problem asks us to take away 8. We don't have enough pieces on the mat to fulfill that request. When we look to the tens column to borrow a rod, we see a 0. There is currently nothing in the middle lane to help us. To find more units, we have to unbundle 100 a flat. We move 100 over and break it apart into 10 individual 10 rods. Now that the middle lane is full, we can take one of those new 10s and unbundle it into 10 ones. Our ones total rises to 13, giving us exactly what we need. Now we subtract. 13 minus 8 ones is 5. 9 minus 6 tens is 3. And 4 minus 100 is 3. Our result is 335. Even when a column starts at 0, unbundling allows us to pull value down from the larger tiers to perfectly complete the subtraction problem. Let's see how this looks with 425 plus 290. The pieces are lined up and ready. In the ones column, 5 plus 0 is 5. Since it's less than 10, no bundling is needed here. In the tens, 2 plus 9 is 11. We bundle 10 of those rods to make 100, leaving 1 10 behind. In the final column, 4 plus 2 plus the carried 100 gives us 7. The total is 715. Whether the numbers are small or extremely large, the physical mechanics of bundling and unbundling stay exactly the same every single time. Remember the rule: when a column reaches 10, bundle up. When you don't have enough to take away, open a bundle from the next place over. Look at this problem: 600 minus 247. With 2 zeros in the top number, think about which column you would have to unbundle first to get the pieces you need for the ones place. By keeping your columns aligned and following these rules, you can solve any problem within 1,000. I'll see you in the den.
Line up each place. Add or subtract carefully. The inverse checks.